because you'll be doing different parts to this depending on where you're sort of up to. Some people might, you can set off either doing infrastructure as a service straight off, or you can go on and do the data store as a service at the start to it. As long as you do both, that's okay. But the idea of infrastructure as a service is to exploit this idea of virtualization that's been around for a long time now. The virtual machines have been around for a good number of years, and many people are using them in other sort of environments, again, such as that mobile app development where you've got that virtual machine of running your Android virtual device inside the Mac or the PC for it. Can cause some sort of confusion running that when people sort of think it's still part of the original Mac, and you talk about where's the local host and that sort of an issue. Here we're having a look principally at the Amazon Elastic Compute product to it. We'll also have a look at the Google ones. There are various resources offered as services. It doesn't have to be the whole virtual machine, the whole just setting up a virtual Linux server and ready-made operating system with it and database sort of set up on it. It could just be that you want database storage linked into an application that's running on your local machine, or you just want remote file storage. And plenty of places have been sort of offering this, whether it's things like Rackspace or Dropbox. You can set up a Dropbox account so you can read and write to it from your application. So rather than writing locally on your disk, you write into that sort of virtual disk. Or you can go for the whole set of it with the Amazon Elastic Compute or the sort of Google one. But the key sort of things is this idea of instant provisioning to it, nothing being local for it. So you can create new machine instances immediately. You'll be doing it initially through a nice little GUI that does it. And instant depends on how fast you can work through these different screens. But if you can get into the script writing part of this and do it at command line, then these things can be automated even more to working with it, so you can run unattended for it. But we'll be showing you how to fire up new machine images as sort of needed. But the general idea, how they're sort of working, is to take this normal component of a computer system, where you've got an operator, where you've got your sort of hardware sitting underneath all your sort of processors, disks and memory and all that sort of thing. You've got some drivers sitting on top of that, and then your operating system, and it doesn't really matter which operating system you're using, but then you write applications sitting inside that. That's the thing just running on your laptop now, presumably, for it. And your applications just supporting your sort of users' needs for it. So the hardware is accessed by a single operating system, and if you want more than one operating system, unless you start using virtual machines, then you need a completely separate machine to sort of run it on. So you may prefer Linux for your server work, you may prefer a Mac for your front end work for it, or Windows for your sort of front end for it. And some of the problems that crop up, failure of an application can interfere with other applications like excessive CPU or memory usage. And I may have mentioned before that some of you who sort of live in shared accommodation may have had sort of problems, say with people doing file sharing in the house. And somebody's busy using BitTorrent to download, which is notorious for hogging bandwidth to it, even though it might not actually be physically using it to sort of download. And somebody starts using something like BitTorrent, and everybody's machine sort of starts to crawl. Or it might be excessive CPU memory usage on an individual machine, like you see in some of the labs sometimes, or running things like Android Studio on your own machine, and the machine all just grinds to a halt while it's running this virtual machine inside it. And it not only might cause operating system failure, but affects other people to it. So what we have with sort of separate servers is trying to isolate applications, both for security or for running their specific needs on. But it can result in underutilised hardware resources. And this old chestnut about you don't potentially really use your laptop 24 hours a day. Most of the day it's sat there doing nothing. But then you have occasional bits in labs where you start to use it, but then it's sort of not doing anything for the rest of the day. And server farms sort of exploit some of this to sort of share out the ideas. But virtualization is really the thing that sprang up out of this. As I say, it's been running for sort of many years now, but it's just come more to the fore with the ability to be able to get these sorts of things on demand, where you create a virtual machine with your own sort of resources, but you don't actually know which true machine it's running on. And what we have is a range of operating systems and a range of virtual devices managed by something called the hypervisor that decides how many machines or virtual machines it can actually run on one specific setup for it. Now, the types of hypervisor that you might have is one that runs directly on the machine hardware, and a hosted one that runs on a conventional operating system that you may well have come across. So the idea being that on top of on a sort of embedded one, you have your physical hardware, and you have this basic hypervisor sitting there on top of it, which loads up an operating system as just a block of an environment block to use, a guest operating system, if you like, to be able to run two operating systems side by side. Now that's a similar approach to, as I say, anybody who's done already things with, say, Android Studio and running that Android virtual machine alongside the Mac. It's a type 2 that you got with the Mac there, sort of thing, because at that sort of level, both the Linux and the Windows machine have got the same level of access to that underlying hardware inside. Whereas if you take the sort of other side, you have a host operating system where you might well run individual applications, but you can run some virtualization systems to run other operating systems inside that core one. For example, on the Mac, you can have the host operating system on there and then run something like Parallels, which allows you to run Windows system inside it, and then you can run the Android virtual machine inside it. Now, yes, it will hammer your machine somewhat. Typically these base machines need to have plenty of memory, fast access to your more sort of like solid state disks and things like that, to be able to switch between this entire operating system and swap from one to the other. And that's where this Docker approach has come in as well. A sort of scaled down version of it, where you collect together the actual sort of software that you need, the stack that you need, if you like, and then push that out to people to run on an operating system, rather than them having to install a whole sort of range of software for it. So it's basically decoupling the application and operating system for the hardware. It makes it much easier to upgrade that hardware then. You can have multiple virtual machines running on one machine. We do have a VMI working already here at MMU. I can just sort of quickly dig it out. I've got a link to it. We used to have this. We used to have this available for all students, but now it's only available for the game students. this is where you can set up a virtual games design workstation. Is anybody on the games pathway? In here? But no. We were finding that some of the hardware required for the games pathway, well, either students didn't have it, or when you were running some of this software, it was just too much to actually run on an individual machine. So we've got a series of virtual servers set up where you can run this just in a browser window to start up. I'm not sure, I've never actually tried their games one. We did used to have the same sort of things that you've got in the labs, like a science and engineering image, or a generic sort of image to it. The only reason they stopped it was that they had problems with licenses. But it wasn't our hardware that were having sort of problems with, they were having problems with managing things like Adobe licenses where we didn't know how many. Yeah. I guess that might be just because I don't have access to the games one. I've not tried it this year for it. Some sort of backup and stick. I probably need to install something else on my machine, but if you were on this sort of games pathway, that would be the sort of environment that you'd be working in. But it does allow multiple virtual machines to run on one machine, and so long as that machine